Hello again. Okay, so this is our second word problem video. This one's on coin, money or coin problems, and rectangle problems. Now, these are going to feel more difficult to set up than the age and integer problems, at least most people think so. So it's really important that you pay attention to the little details and the little nuances. Okay, so in a coin problem, usually you have one person who has some money in the form of coins, and he or she may have two types of coins or three types of coins. Rarely are you going to see four types of coins, because then the problem gets a little messy to solve. In this case, we have Paul, who has three types of coins: nickels, dimes, and quarters. And in case some of you aren't sure, nickels are 5 cents, dimes are 10, and quarters are 25. And now it describes the relationship between the numbers of nickels, dimes, and quarters that he has. There are 3 times as many nickels as dimes, and 4 more quarters than nickels. Okay, so 3 times as many nickels and dimes, so the nickels outnumber the dimes, and 4 more quarters than the nickels, so the quarters outnumber the nickels. Now this sentence, the next sentence, has nothing to do with number of coins. It just is stating how much money value that he has. The total value is $9. Notice that's given in dollars, not cents. And your job is to find how many quarters Paul has. They only want to know the quarters. So we're going to set up 2 equations. To start off. The first equation is going to be describing the number of coins. The second equation is going to be our monetary value equation. So first, the number of coins. Actually, this is going to be 2 equations. So there's going to be a grand total of 3 equations. So number of coins, I go to this sentence. There are 3 times as many nickels as dimes. Stop. That's going to be 1 equation. 3 times as many nickels as dimes. So that means that n, the number of nickels, is 3 times d, the number of dimes. I should say that n equals number of nickels, and d equals number of dimes. And we're going to have a q for quarters. So quarters, q equals number of quarters. Okay, so that's my first sentence from here. And my second sentence will come from here. There are 4 more quarters than nickels. So quarters is n plus 4. Okay, so I'm done with the 2 little equations describing the number of coins. Now I go to what's going to be the long equation, the equation that describes the value of all the money Paul has. He has $9. In cents, $9 is 900 cents. So he has 900 cents in the form of nickels, dimes, and quarters. Okay, so I'm going to set up an equation where the value that he has in nickels, dimes, and quarters are on the left, and the 900 cents are on the right. So that means I'm going to have three things on the left side that are added to each other. The value of nickels, the value of dimes, and the value of quarters that he has. Keeping in mind that every nickel is 5 cents, every dime is 10 cents, and every quarter is 25 cents. So let's start with the nickels. $5N, $10D, $25Q. Now, I can't solve this equation the way it is because I have three variables in it. I need some help. Where does my help come from? It comes from these two little equations. So using these two little equations, I can alter this equation so that it only has one variable in it. And I can choose whichever variable I want it to be. I could make everything in terms of N, I could make everything in terms of D, or everything in terms of Q. Now I'm deciding right now that I want everything to be in terms of I'll just pick randomly one of these letters and see how it goes. So since N is coming first, I'm going to pick N. So I don't need to change 5N, I'll keep that. I need to change that D. So I look up at my little two helper equations, and I notice that there's an equation with N and D in it. So I'm going to solve for D, isolate D, get D equals something in this equation. So to solve for D, I need to divide both sides by 3. So D equals N over 3. Okay, now I can replace this D with N over 3. Substitution. Now here, I want to replace the Q. I want it in terms of N, just like these two terms. So I go to my other helper equation. Q equals N plus 4. I don't have to do anything with this equation, it's all ready to be used. So I replace this Q with N plus 4. Okay, I've accomplished what I wanted to do. Everything in this equation is in terms of N, or a constant. In any case, there's only one variable in my equation, so I can start solving. I should eliminate fractions first, so I'm multiplying everything by 3. And I'm going to do two things at once now. I'm going to add the 15N and the 10N and then distribute the 75. Combining like terms. Subtracting 300. Dividing by 100. Wait. Yeah. So I have 24 nickels, and they're interested in how many quarters. They're interested in Q. So I can take my 24 and plug it in right there. So Q equals 28. So my official answer to the question is 28 quarters. Okay, so that's your coin problem. I mentioned that I could solve it a different way, so I'm going to do that right now. So going back to this equation where I have n, d, and q, I could, instead of changing everything in terms of n, I could make everything q. After all, that's what they want to know. They want to know what q is, right? So why not change everything into q? Alright, so I go to the 5n, I got to change that into q. Well, I go to my helper equation here because I have q and n in it, and I solve for n. N is q minus 4. So I can replace this n with q minus 4. Now I'm at 10d. So I need to replace d with something. Well, I don't have a q in this equation, the helper equation. I just have n and d. But I just found out that q minus 4 is the same thing as n. So I can replace this n with q minus 4. And I'll write what I get down here. So if I replace that, I get q minus 4 equals 3d. And then divide both sides by 3. Q minus 4 over 3 equals d. So now I can put this in place of this d. Q minus 4 over 3. That's a q. And the 25q has a q, so I don't need to change anything there. Okay, now everything's in terms of q. I will multiply by 3 like I did last time to get rid of the fraction. And then distribute. Combine like terms. And I get the wrong answer. So this is where we go back and find our mistake. Okay, so we're going back to here. I know that's correct. So maybe something happened here in the substitution. So I go back to my helper equation. Does n really equal q minus 4? Yes, it does. So that was correct. Then I go to my 10d. Does d really equal q minus 4 over 3? Put q minus 4 here. Divide by 3. Yes, it does. I'm going to put a check mark here, check mark here. 25q didn't change. 900 didn't change. Okay. I multiplied through by 3. I multiplied 3 here. I multiplied 3 here. I did not multiply 3 here. And I didn't multiply 3 here either. Okay, so I think I found the mistake. So I'm fixing everything in all the subsequent steps. This should be 100q. 100q. And that makes q 28. Okay, there we go. That's the coin problem. And now I'm going to show you the rectangle problem. And then we'll be done. Okay, length of a rectangle is 10 greater than twice the width. It's always a good idea for a rectangle problem to draw it. So the length is the longer side, so I'm going to make this the length. So length, width. The length is equals 10 greater than twice the width. So that's 2w plus 10. 2w plus 10 and w. Now, in the second sentence, it says if the length is doubled. So now we're picturing a new rectangle. So I'm going to draw another one. Except that's the wrong picture, so it's going to be more like this. Okay, so forget that. The length is doubled, so times 2. And the width is halved, cut in half. So now the widths are w over 2, w over 2. So if that happens, the original perimeter would increase by 80. So the sum of all these four sides, if I change them to this, the sum of these four sides would be 80 more than that. That's where my equation is going to come from, this part. So what I need is one side to be the perimeter of the original rectangle, the other side to be the perimeter of the new rectangle, and then I need a plus 80 on one of these sides to show that the perimeter has increased. So first, the perimeter of the left side would be 2 times 2w plus 10 plus w. My right side would be the perimeter of this rectangle, 2 times 2w plus 10 plus w over 2. Okay, now remember the perimeter increased from original to new rectangle. So for this to be equation, the plus 80 must go here. The original rectangle's perimeter plus 80 is equivalent to the new perimeter. Okay, I have an equation with one variable, so I know I can solve it. I'm going to distribute this too. I'm not going to distribute this 2. I'm going to distribute the one inside here first. I'm going to combine like terms here. And I'm going to distribute this outer 2 here. I'm going to get all variables on one side. And I'll move this, subtract 100 on both sides as well. So I get a width of 20. I need the length too. The length is going to be 2w plus 10. I'm getting that from up here. So that is 2 times 20 plus 10, which is 50. So the dimensions of my original rectangle, 20 by 50. Official answer, 20 by 50. Okay, that's a rectangle problem. See you next time for more stuff.